This port moves 20 million containers a year without a single human ever touching a steering wheel. It is a 24/7 game of high-stakes, real-world Tetris. We are standing at the edge of the world's most advanced logistics frontier. It is May 2026, and the way we move goods across the planet has fundamentally shifted. For decades, shipping ports were the loudest, most chaotic places on Earth. They were hubs of human grit, shouting, and the constant smell of diesel. But today, the most productive ports in the world are eerily silent. There are no drivers in the trucks. There are no operators in the crane cabins. There is only the low hum of electricity and the invisible pulse of data. Welcome to the era of the ghost ports. To understand how we got here, we have to look at the scale of the problem. Over 90% of everything you own reached you by sea. Your smartphone, your clothes, the components in your car, and the coffee on your desk. The global supply chain is a massive, interconnected web that depends on the efficiency of a few hundred key nodes, the container terminals. For a long time, these terminals were the bottleneck. Human error, fatigue, and the physical limits of manual labor meant that ports had a ceiling on how much they could process. But in 2026, that ceiling has been shattered by logistics engineering. The transformation is driven by three core technologies: LiDAR, 5G, and algorithmic sorting. When these three systems are synchronized, they turn a massive shipyard into a giant, perfectly calibrated machine. It is not magic, it is a triumph of smart infrastructure. Let us break down the anatomy of this machine, starting with the eyes of the port. In a traditional port, a driver relies on their vision to navigate a 40-ton vehicle through a maze of steel. In a ghost port, the vehicles see through LiDAR, or light detection and ranging. These sensors pulse millions of laser beams every second, creating a high-resolution 3D map of their surroundings in real time. This is called a point cloud. To an automated guided vehicle, or AGV, the port is not a collection of objects, but a mathematical coordinate system. It knows the exact position of every container, every crane, and every other vehicle within a fraction of a centimeter. But seeing is not enough. These machines need to talk to each other. This is where 5G comes into play. In older automated systems, Wi-Fi was the standard, but it was prone to interference and high latency. In a high-stakes environment, where a 1-second delay can cause a multi-million-dollar collision, Wi-Fi simply was not safe enough. The 5G private networks installed in these ports provide ultra-reliable, low-latency communication. We are talking about a response time of less than 10 milliseconds. This allows the central control system to orchestrate hundreds of AGVs simultaneously, ensuring they never cross paths or waste a single second idling.
Imagine the logistics engineering required to manage this. Every time a massive container ship docks, it carries up to 24,000 TEUs, or 20-foot equivalent units. Unloading a ship of this size is a logistical nightmare. In the past, it took days of manual labor. Now, the ship-to-shore cranes, which are also fully automated, reach down with surgical precision. They are equipped with computer vision systems that can identify the exact locking points on a container, even as the ship sways slightly with the tide. Once the crane lifts the container, it places it directly onto an AGV waiting below. These AGVs are the workhorses of the ghost port. They do not look like trucks. They are flat, robotic platforms powered by massive electric batteries. When an AGV runs low on power, it does not go to a gas station. It navigates itself to an automated battery swapping station. In less than 5 minutes, a robotic arm replaces its depleted battery with a fully charged one, and the AGV is back on the line. This 24/7 operation is something no human workforce could ever match. There are no shift changes, no lunch breaks, and no fatigue-related accidents. But the real genius of the ghost port lies in the brain, the algorithmic sorting system. This is the real-world Tetris I mentioned earlier. Moving a container from a ship to a truck is not just about moving it from point A to point B. It is about moving it in the most efficient sequence possible. If a container that needs to be picked up tomorrow is buried under 10 containers that are not leaving for a week, you have a problem. This is known as the stacking problem. The software governing these ports uses predictive analytics and machine learning to solve this. It looks at the departure schedules of every truck, train, and ship connected to the port. It calculates the optimal position for every single container in the yard.
As containers arrive, the automated stacking cranes place them in a way that minimizes future movement. If the algorithm realizes a container needs to be moved to a more accessible spot, it will schedule that move for the middle of the night when the port is less busy. This constant invisible reshuffling ensures that when a truck arrives at the gate to pick up a load, the container is already at the top of the stack, ready to go. This level of efficiency has a massive ripple effect on the global supply chain. By reducing the turnaround time of ships, we reduce the amount of fuel they burn while idling or waiting for a berth. This makes the entire shipping industry more sustainable. Furthermore, the precision of robotics means that damage to goods during transit is almost entirely eliminated. In a ghost port, there are no hard landings or accidental bumps. Every movement is calculated to be as smooth as possible. However, building a ghost port is an immense engineering challenge. It is not just about buying some robots and turning them on. It requires a complete rethink of smart infrastructure. The ground of the port must be perfectly level and embedded with thousands of transponders or magnetic nails to help the AGVs calibrate their position. The digital twin of the port, a virtual replica that lives in the cloud, must be updated in real time to reflect every single physical change in the yard. This allows engineers to run simulations and predict potential bottlenecks before they happen in the real world. There is also the question of cybersecurity. When a port is controlled entirely by code, the code becomes the most vulnerable point. A single hack could paralyze global trade. This is why the robotics and IT architecture of these terminals are built with multiple layers of redundancy and air-gapped systems. The security protocols are as rigorous as those of a nuclear power plant. The engineers managing these ports are no longer wearing hard hats on the docks. They are sitting in high-tech command centers miles away, monitoring data streams and ensuring the algorithms are performing optimally. This leads us to the human element. Critics often point to the loss of traditional dock worker jobs, and it is true, the nature of work at the port has changed forever. But the ghost ports have also created a new category of high-tech jobs. We need robotics technicians, data analysts, 5G network engineers, and software developers who specialize in logistics. The grit has moved from the muscles to the mind. The ports of 2026 are safer, cleaner, and more efficient than anything we imagined 20 years ago. We are also seeing the rise of intermodal automation. The ghost port does not end at the shipyard gates. It connects directly to automated rail terminals and autonomous trucking corridors. In some parts of the world, a container can now travel from a factory in one country to a warehouse in another without ever being touched by a human. This is the ultimate goal of logistics engineering, a frictionless, invisible flow of goods. As we look toward the future, the technology developed for these ports is already trickling down into other industries. The LiDAR systems used by AGVs are making self-driving cars safer. The algorithmic sorting methods are being applied to warehouse management and even urban planning. The ghost port is not just a place where ships dock. It is a laboratory for the future of human civilization. To see a ghost port in action is to see a vision of perfect order. In the dead of night, under the glow of LED floodlights, these massive machines move with a grace that seems almost choreographed. There is no shouting, no honking, just the quiet whir of motors and the occasional click of a container being locked into place. It is a reminder that we are living in an era where the most complex problems are being solved not by force, but by intelligence and precision. The ghost ports represent the pinnacle of our mechanical and digital capabilities. They are a testament to what happens when we treat the world's most difficult problems as engineering challenges. By removing the limitations of human physical labor, we have created a system that can keep up with the demands of a global population that never sleeps. It is a 24/7 symphony of steel and silicon. So, the next time you track a package or buy a product from across the ocean, remember the silent giants working tirelessly at the water's edge. Remember the LiDAR sensors scanning the horizon, the 5G waves carrying commands in milliseconds, and the algorithms playing a never-ending game of Tetris to make sure that package reaches you on time. The ports might be empty of people, but they are full of human ingenuity. This is the reality of logistics in 2026. This is the world of the ghost ports. It is not magic. It is the result of thousands of hours of engineering, the application of cutting-edge physics, and the relentless pursuit of efficiency. We have turned the gateway of global trade into a giant, perfectly synchronized machine, and this machine is just getting started. As we move further into this decade, The distinction between the digital and physical worlds will continue to blur. The ghost ports are just the beginning. Soon, every step of the supply chain will be part of this autonomous network. We are building a world that works for us, even when we are not there to pull the levers. The future of logistics is here, and it is silent, efficient, and entirely autonomous. Thank you for joining us on this deep dive into the engineering behind our modern world. At Not Magic, we believe that the most incredible things are the ones we can explain through science and logic. The ghost ports are a perfect example of that. Until next time, keep looking for the mechanics behind the mystery.